Today, folks, we have another maintenance type repair to do here on our house, getting into something that isn't my favorite thing to do in the world, plumbing. But there's something that needs attention here with my well pump. Now what I have here, I'm in the back part of the laundry room here where I have the above ground components of my well pump watering system. There is a submersible pump in my well, which is outside on the other side of this wall. I think it goes down about 60 feet, I can't remember, but it has good water and it never runs dry. That's the most important thing. The submersible pump's been in there for, I'm going to say about 17 years or so now, and still working fine. About, I guess it was 5 or 6 years ago, 5 years ago I guess it was, I had to replace a few of the components up here. So what I basically did is I just replaced everything that was above ground here. Now let me walk you through this. What's happening is, and the reason for this repair is that I'm having trouble with the well pump short cycling. In other words, maybe you've been hearing the clicks even since I've been starting to show this video. The pump is kicking on and off more frequently than it should. Now, there were two possibilities. I've checked the one already, and it's not that. One is if you have incorrect pressure in your pressure tank here, that can cause it to do that. What it's doing is basically it's constantly calling for water from the well pump, and then when it fills it up or the pressure goes up, then it turns itself off. And that's the way it's supposed to work. Now that works by means of, let's see if I can get back in here and show you. Some extra light. That little gray box right there is a pressure switch. And it's connected, you can see the gauge there and also the other components. Underneath the pressure switch to the right on your picture is where the line is coming in from the well. Then it's coming out. That rise tube there controls the monitors the pressure, and then it comes into this expansion tank here, and then it comes out. This is my main feed out here coming into your 3/4-inch PVC to power the whole house, or excuse me, to put water through the whole house. Now the way this system works is it's a pressurized system. You can get different pressure switches rated for different pressure amounts. The one that I put on here is a 4060. You can see I have it written there to remind myself, which means is that when the pressure drops down to 40 pounds, then the well pump kicks on, and then as the water's pumped in, the pressure increases until it gets up to 60 pounds, and that turns the well pump off. Now the way that works is in this tank, there is, in the top part of the tank, there is a rubber air bladder. And what happens is when the water is in the bottom half of the tank, and if you have a tank like this, especially in the summertime, you can see that usually the bottom half only has condensation around it, the top half doesn't. If your whole tank is covered with condensation, then maybe you've got a problem, because the top half should just have air in. But what happens is when you want to get water through the house, the air in the bladder is actually helping to create pressure to push it through the house at your desired PSI, pounds per square inch, to give you water pressure at your faucets, your sinks, your toilet, your shower, etc. And for a well pump, this is about the average. In a typical well pump, you're talking maybe 40 to 60 pounds of pressure that you will have. If you have city water situation where you have a water main coming into the house, you don't have this, because it is you have constant pressure coming from the head pressure from your whatever your water source is. If you have a reservoir up the hill from the town, or you have one of those big tanks in the middle of town, one of those water towers. The pressure of the weight of the water pushing down pushes it through the pipes generally. And in fact, a lot of towns, you even have an amount of pressure that they actually have to put a reducing valve on your line coming in, because you don't want more than 90 pounds of pressure or your pipes can't handle it. But out here in the country, when you have a well pump, you don't have that much pressure because you're drawing water out of the ground. It's not being pushed down the hill, so to speak, from the surface reservoir or from the water tower. So you've got to create your own pressure, and that's what this expansion tank does. So the way that this operates is, this particular one requires that you put air in the bladder, the air bladder that's in there, to the point of 2 pounds below, 2 psi below the lower limit of the pressure switch. So since this is a 4060, I want to keep 38 pounds per square inch of air pressure in the tank so that it functions properly. Now this, let's see if I can do this with the flashlight in hand. This cap right here is just like the cap on your car tire, and that's exactly what's in here, is just a typical valve stem, and that's how you add or subtract air. I did check that first. I corrected the pressure in there to 38 pounds and found out that that's not my problem. Now the way you're going to do that, if that's your first step, you need to turn off the well pump, and you need to open faucets, preferably near your expansion tank, and just let the water run out so that it drains the pressure out of the system, so that there's nothing pushing on the air bladder as far as water goes. You only want whatever air is in the tank to give you your reading. So that's what I did, and that's what I'm going to have to do here again today. I'm going to have to turn the power off and then bleed the line, so that the gauge down there will show me that I don't have any air pressure coming in, or any water pressure created. And then I've got to change out this pressure switch. Now, as I said, this switch is about maybe 5 years old, so I don't know why it's gone out on me exactly yet, but I got another one. I'll just replace it instead of fooling around. Sometimes the contacts get scored or corroded, and we've had a lot of humid weather over the last couple summers, so maybe that's part of the problem, that the contacts are corroded, so it's not turning on and off properly. You don't want this to continue, because eventually your whole system could get some damage, or your well pump could wear out. Now with a submersible pump, you don't need to worry too much about the pump burning out, because it's all underwater. It's cooled. If I had what they call a jet pump, which is a surface pump, which instead of pushing the water up, it sucks the water up like a straw, that electric motor could burn out easier than a submersible. That's why submersible pumps, I think they say they're good for 20 and 25 years if they're not overused and they're properly sized for the amount of water. So I won't get into all that today, and again, I'm not a big expert. I'm just telling you what I have here and what I need to do. So this isn't a very difficult job to do. I've got to pull that cap off and then take the unit off, and I'll show you that as I walk my way through it. I sort of have it jammed back in here in the corner because my space is a little limited here, and I didn't want to take up too much room in this corner of the laundry room. So it's going to be a little tight to do it, but I'll try to walk you through it. The first step in any of this is obviously safety. So the first thing that you want to do is come to your panel box and find your well pump and turn that breaker off. So now I know I don't have power going to that that unit. And remember, it's this is a double pole breaker, so that means I am running 220 volts to that well pump. So there's 220 volts in that little pressure switch there. So I don't want to mess around with it with the power on, because that's could be deadly if you're not careful. So safety is always most important, so we want to turn the power off before you do anything, and that way you know you're safe. It's a 20 amp breaker, as you can see. So it's just a piece of, oops, pull back a little bit, 20 amp breaker. It's just a 12-2 piece of wire that runs down, and I just have it surface mounted here because I'm in the back corner of a closet, so I wasn't too worried about any kind of problems with that. And then that connects into there, and there's a 4-wire lead that comes off of this and actually goes down and attaches to the well pump itself down in. There's a waterproof seal in there. You don't have to worry about it shorting out or anything, but that's attached right to the well pump itself. But this is the switch here, and it's designed to work with pressure so that you don't have to worry about having not enough pressure or too much pressure or burning anything out. But when this unit starts to go, then you've got to replace it so that the system works properly, and that's where I am. So I'll walk you through this. It's not a difficult repair, and it's a bit more electrical than it is plumbing, which is good for me. But we'll get this replaced, and that should stop the short cycling, and we should be good for at least hopefully another 5 years on this. I've got to remember this time to write the date on the outside cover, just like I put this information on here. That way I'll know how long I've had this in if I have to replace it again or somebody else does. So at any rate, let's get started with this. Hopefully it won't be too involved or have too many problems, and we'll be back to normal. Okay folks, second part of this repair. Now what I did was I took the cap off the pressure switch here, and I watched it in operation, and it turns out there's not a problem with the pressure switch. It is working properly. You can see there it just kicked on. The contacts moved together. Sorry about the light there. And it is refilling the tank. Now if you watch that for just a couple minutes, you'll see it kicked off when it reached 60 pounds. Kicks on at 40, kicks off at 60. So the switch is working properly. It's not a bad switch, but this is what I did find. If we come down here, I don't know how well you can see that. That's the pressure gauge. And if you look at it, what you're seeing is the pressure is dropping. Slowly, but it's dropping. This should not be happening. And that's why the pump is kicking on and off so often, because what is happening is after it fills up with pressure, then it fills up with water and the pressure increases to 60, then it loses pressure. And if you watch just a second, when it gets down to 40, you'll hear the switch kick back on. It's just about down there now. See it just about any second now. It should kick back on. It's just about down to 40. There, kick back on. Now watch the pressure go back up, which is what it's supposed to do. And when it increases up to 60, climbs up to 60, then it'll turn back off. You hear the click again. Right there. Alright, so what's happening? Well, I didn't know. I'm sorry about the camera here for a second, folks, while I get back up. I didn't know because I never had a problem like this before. So what I did is I went online and I read a couple various sites, and what basically is happening, the reason that pressure is dropping when nobody is pulling water is there's got to be a leak in the system somewhere. So there are two possibilities. Either there's a leak in the house line here somewhere at a faucet, say, or a running toilet, or an outside spigot that is dripping. That would do that so that the pump constantly runs. The issue is, though, I have gone through the entire house. I have checked every outlet for water, faucets, spigots, toilets, showers, outside faucets, the washer, everything, and there is nothing leaking that I can tell. Now, the other possibility is the leak is at the other end, and this is the thing that I feared and was warned about online. when this line, put the light on again for you to be able to see. When that line there, that pipe, goes out through the wall, into the other room, and down through the floor, and then out to the well. When that goes all the way down to the well, when it gets to the pump, the well pump down in the well, right before that, attached to the top of the well pump, is what they call a check valve. And I'll show you what they typically look like here. It's a check valve. Now what a check valve is essentially a one-way valve. Sorry again, I'm not a good picture, but I'm just trying to open this box so you can see it a little better. A one-way valve. It allows the water to flow in one direction but not back the other way. It prevents backflow, and there are a number of applications for these in plumbing, whether in drains or what have you. But this one, as you can see, I don't know if you can see down in there or not. Let's see if I can turn it there. You might be able to see a little better that way. You can see when I push it from the other side, it opens. If I look this way, this is a spring-loaded gate in there. So when I push on it, and what happens is when the well pump starts up, the pressure from the well pump pushes this open. The water flows out from this side and up through the pipe into the house. But what must be happening down there, at least this is the theory, is that this has become defective. The gate no longer works. And what is happening is when this expansion tank reaches 60 psi, there's a significant amount of back pressure. And what's happening is instead of just pushing the water forward through the house, through the lines through the house, it's also wanting to push backwards down into the well. And some of the water is going actually back down the pipe, and because the check valve isn't stopping it, it's flowing back into the well, and that's why the pressure is dropping the way it is. At least that's what the theory is. So their suggestion is you have to pull the well pump out of the well and replace the check valve. My problem is it's February. There's no way in the world I want to be standing outside now trying to pull up 60-80 feet of pipe and wire and so on, and pull a well pump all the way out of the well and then replace that and put it back down in. The other thing is, as I said before, I think the well pump's been in there for about 17 years or so. I may have 5-7 years life left in it yet. So if I'm going to pull the whole thing out to change the check valve, it only makes sense to change out the well pump, so you don't have to do this twice in a number of years. But the problem with that is a new well pump is $300 to $400. So my repair just jumped, by orders of magnitude if I have to do all that. So I'm going to try something a little different. What I'm going to do is I'm going to attempt to put this check valve, what would actually be a second check valve, in the line down here on the well side of this apparatus. And my hope is that the check valve right there will stop any backflow, any pressure pushing down. But that when the well pump pumps, it'll still open, it'll still have enough force up here to push it open so that the water flows into the system here. I'm hoping that will work. It'll save me a whole lot of time, a whole lot of money, but it's going to involve me tearing apart that polyethylene or whatever the plastic is of that water line, taking it apart and kind of rebuilding it with the check valve in line. So we'll see how that goes. It's an experiment. I've never tried this before. I don't know if it's the best way to do it. But before I go to the extent of pulling the entire well pump out of the well and do a rebuild on it or replacement on it, I'm going to try to get away with doing this and see if that doesn't solve my problem. The other issue, and that hasn't hit me yet, but I'm sure it will, with the well pump running so often, my electric bill is going to be sky high for the next month because It's a 220 line, and it's running every couple minutes. So there's always a surge of electricity every time a motor turns on. Most of the electricity you use in applications like that is when the motor starts till it gets up to speed, and then the amount of electricity to keep it running is less. So this on-off is much more expensive than if it was just running steady. At any rate, let's see how that goes, and I'll keep you along for the ride. So thank you for watching. Now, to prep this, to put it in, I have to connect it to the plastic pipe with this kind of a connector. It's ridged on this side so that it'll slide and bite the inside of the pipe, and then I put a radiator clamp over the top. On this side, I've got a male thread because it threads into the female opening on the check valve. You can see I've already put one on. And I'm using Teflon tape to try to make sure I have a tighter seal. Again, when you're putting it on this way, because of how the threads turn, the standard threads, you're putting your Teflon tape on clockwise so that it flows in the same direction that you're tightening so that it stays in place. Now, another thing I did just for my benefit and the benefit of anybody else who might work on this, if they're not a plumber, you can see here on the check valve that there is a little arrow stamped to show you water flow direction. But I've also, with a marker, put a couple more arrows on to make sure that that gets put on right. If you put this on backwards, no water will come out of the well, because the check valve will work against you. It'll keep the valve closed when the water pressure is against it. So it only works one way, and you want it to open this way as the water flows through this way. So that's just a little reminder for me and anybody else to make sure that they understand what's happening. Somebody who's a more experienced plumber would know, but if you're not, at least this is just a little, it doesn't hurt to mark things, you know. Assume that somebody doesn't know what they're doing and make it easier for them. So that's why I'm doing that. So alright, so I've got to put this on, and then I've got to tear out the old pipe there and kind of build a new construction of it flowing from the line into the apparatus there that controls it, and make sure that it's watertight. So I'll come back to you with the next phase. Okay, first change in plans on this job. So I cut the line coming in, and I loosened the clamps on the hose, or on the pipe coming into the unit here. My issue is the size of the check valve with the nipples on it. It was too long. I don't know if you can see that, too long to really fit the way the pipe was, so I couldn't just cut a piece of pipe out and shove it in. So I've got to basically replumb this whole thing. I have the stuff to do it finally, 2 quick trips out to the plumbing supply store. But the other thing that I need to do here, I've got to slide the whole unit to the left so I have room to work, and then fit this in first. Now, one of the mistakes I made when I put this in here, this is the main supply line coming into the house, and what I should have done is made it easy to disconnect the expansion tank unit from the supply line, so that if this ever came up like is now, and I needed to work on it, it would be an easy job. I mean, I'm going to have to now cut that line because I've got to slide everything else to this side, so that won't flex that much. And then what I've got to do is put one of these in. It's a 3/4 inch PVC union. So that way now, when I go to put it back, I can reconnect it up. I might have to angle my pipe a little differently. I've got pieces to do that. Whatever has to happen happens. But then also in the future, if I should ever have to work on this again, it'll just be a question of loosening this nut, and the pipe will come apart right here, and I can just slide the whole thing away from where it was. So you learn as you go, I guess, and this is probably something that's more standard that plumbers would do, just putting a quick disconnect kind of union in there. It's just solvent welded glue at both sides and then tighten up the nut, but it's something I'm going to have to do. So my first move is going to be to cut this. I've got to figure out whether I want to cut it high or low. And then I can slide this whole unit out further this way, and then I can rebuild that section of water line coming in with the check valve assembly here connected in. So I'll come back to you when I'm ready for the next step. Well folks, here we are. You can see I've got the check valve is in. I kind of replumbed my supply line coming in as best I could get it. I had to slide the whole unit over about 6 inches. So I think I'm good to go there. A little bit of water on the floor, not much. But because of sliding this over, what I had to do is I had to change this situation for the supply line. So instead of coming straight up into here, I put a union in here like I said I was going to do so I can disconnect it. But I had to put 245s in to bring the pipe over, because I'm almost a foot further, six inches to a foot over from where I was. Doesn't look pretty, but I'm hoping that it works. I'm getting ready to turn the system on and see what happens. So we'll be coming. Okay folks, well I think we're about as good as we're going to get it for today. We're all in, attached. Turn the power back on, or the water back on, power back on. I had some leaks here by the clamped areas, so I really had to torque those clamps down as tight as I could. Screwdriver and nut driver didn't do it. I had to get my socket and ratchet and really clamp them down. So pretty much it's dry. There might be a drip here and there, but in time that'll scale over and then that won't be a problem. That happens normally. What I'm seeing is the check valve seems to have solved the problem. The pump is not continually cycling. I know it's dark in here. I didn't bring the flashlight with me, but you saw that before. It's not continually cycling, so I think I got the problem fixed with the short cycling by adding this extra check valve here. Now how long this will last before I have to do some work down in the well, I don't know, but for today I'm happy. One problem I had here was with the union here. For some reason this solvent weld right here failed. It didn't seal properly. So there's a few drips coming off the top of here. I'm not going to do it today because I'm about done with this work for today, but I got to come back and drain this out again and try to re-glue that. The problem is I didn't have my regular glue. I ran to a wholesale place and grabbed some generic stuff that I've never used before. The other weld sealed on this CPVC, no problem, but for whatever reason right here on the top there's a spot where it's leaking. It's dripping out a drip or two at a time. So again, I'm not too worried about that. Yeah, I've got to get it fixed, but but we're back to having water in the house is what I'm saying, and the pump is not continually cycling. There's nobody calling for water now, and as you've heard or not heard since we've done this last part of the video, you haven't heard the pressure switch kick on because it's holding the pressure now. So this appears to be a solution. If you have a problem with this, that maybe your check valve in your well is shot and you don't want to have to go through all the expenses of pulling up the well pump and replacing that, this could be a temporary solution. I don't know. We'll have to see how long it lasts, but for right now it's holding the pressure. The water cannot push back down through the pipe into the well because of the check valve right here. So we'll see what happens. Water pressure in the house seems good, so we're going to call this a guarded success, shall we say. And hopefully if you've got a similar problem, that'll work for you. It might buy you a few years before you have to pull everything up, but you know, like I said, a new well pump is $300-400, and if you're going to pull everything out of the hole, if your well pump is already over 10 years old or 15 years old, you might as well just replace it at that point. So I'm hoping this will get me through a number of years, and we'll have water in the house. So one more job I got to do. It's time to change the water filter, the sediment filter in here. That's not a big deal. And then I am done with plumbing for today, thank God. Thank you for watching. Please subscribe to our channel, hit the notifications bell, and we'll let you know when new videos are posted. So life out in the country on a shoestring continues.